The main astronomical topic of this year is the object 3I divided by Atlas. This is an extremely rare case. It arrived to us from another planetary system, and some scientists even suggest that this object may have an artificial origin. Well, we have already talked about this 3I divided by Atlas, but new data keeps coming in. Astronomers around the world are now actively studying this mysterious object. What is on its surface? How does it move? What exactly is it? And how can we detect such new interstellar visitors? Today, we'll discuss this. This is the Extraterrestrial Podcast. I am the astronomer Orion Vega. If this topic interests you, give the video a like, and let's begin. The most relevant astronomical event that one can talk about every single day for the next half year is the new visit of an interstellar object to the solar system, because this is already the third one. Since 2017, we have received such visitors for the third time, coming from who knows where, from the depths of the galaxy. But the most important thing is that we detected them, found them in the sky, and started studying them. The first was ʻOumuamua in 2017. It is still unclear what it was, either an asteroid, or a dried-up comet, or perhaps even a spacecraft. The second was Borisov's comet, discovered in 2019. And finally, this year, a third interstellar object has been discovered. It is called 3I, meaning third interstellar, and it was given the name Atlas. Atlas is written in capital letters because it is an acronym. Atlas is a system of robotic optical telescopes that scan the sky, almost without human involvement, and find everything that may interest astronomers. In this case, it was an asteroid, but in fact, it was first identified as an asteroid, and later it became clear that it was a comet flying toward us from the depths of the galaxy. However, whether it is really a comet still remains to be seen, although outwardly it resembles one. This object was officially discovered on July 1st, but in fact, it had been observed earlier. People just didn't yet realize what it was. You know, in astronomy this happens quite often. We're used to it. Someone may have seen it, but the author of the discovery is considered to be the one who first pointed out the unusual properties of the object and drew everyone's attention to its nature. But before that, astronomers had also been looking at the sky, photographing it, and studying it. And on older photographs, newly discovered objects are often found. Once you know where and what to look for, it becomes much easier to identify them. That's exactly what happened this time as well. Although on July 1st, it was officially announced that an interstellar object had been discovered, astronomers immediately turned to their archivistidae. Of course, these are electronic archivists and started checking the calculated positions. Where had it been earlier? We don't just calculate the future path of a cosmic object where it will be seen in a few years, months, or days. We always also calculate where it was in the recent past, where it came from, and whether it could have been spotted in older images. This way, we extend the piece of its trajectory that is known to us, and then we calculate its orbit more precisely. This time as well, astronomers working with the Test Space Observatory, well, I almost said space telescope, but then remembered that in fact, the TESS satellite has 4 optical telescopes, 4 lenses, each with a wide field of view, were able to contribute to this effort. This spacecraft was specifically designed to search for planets around other stars, and it is actively discovering them. But the enormous stream of data, which every few minutes is transmitted to Earth and stored in computers, allows us to look back what was happening months earlier in the region of the sky. This interstellar comet was expected to appear, and indeed, they found it. They located it in images taken on May 7th, July. This means that astronomers were able to extend the observable trajectory by 2 months, making it possible to track and then calculate the further path of this object. Every professional dreams of working on complex tasks in a strong team, alongside recognized experts on meaningful projects. And really, what astronomer would turn down an invitation to the KK Observatory? A professor of technical sciences at Moscow State Technical University, or physicists from around the world strive to collaborate with Caltech in California, while those in the humanities dream of Cambridge or Oxford. Many Russian IT specialists dream of working at our tech giant per Index, X5, Tinkoff Bank, ʻOumuamua. If you're one of them, you can check out Big Tech Night, the IT version of Museum Night. For the first time in history, these companies have joined forces to reveal themselves from the inside. On September 12th, they will simultaneously open their office doors at night to developers, managers, engineers, analysts, and everyone passionate about IT. The format was initiated by Yandex. Companies came together to show that behind these brands are people and a living engineering culture. Each office has its own program. You can choose one company or try to visit several. And if you are not in Moscow, you can join the Big Tech Night online studio. There will be 2 parallel streams, deep technical conversations with visionaries, and a light evening show with stories and anecdotes from developers. All of this will be broadcast live from anywhere in the world. Register for free using the link in the description. The IT Night is here. Now we already have a large portion of the trajectory. Let's look at how this object is moving. When 3I divided by Atlas was first observed, it was still in Jupiter's orbit, but it was moving very quickly at a speed of 60 kilometers per second, a colossal speed, and it was this very speed that revealed its interstellar nature. As it approached the center of the solar system, calculations showed that on October 3, 2025, it will pass near Mars. What does near mean? At a distance about 5 times smaller than the Earth's distance from the Sun. 19 astronomical units. At first glance, that seems like a huge distance, millions of kilometers. But the important thing is that near Mars, there are several spacecraft in operation, and they will be much closer to this object than our ground-based telescopes. We will try to observe it with the instruments on board those spacecraft. On October 3rd, it will encounter Mars. Mars, of course, with its gravity, will slightly alter the orbit of this new comet, causing it to bend a little, before continuing its approach to the center of the solar system. On November 3rd, the comet will pass close to Venus. What does close mean? About 100 million kilometers. Still, that's a noticeable approach. On December 19th, there will be an approach to Earth, but this will be a very distant approach. Its closest distance to our planet will be nearly twice the current distance between the Earth and the Sun. Because the comet will be at about the same distance, but on the opposite side of the Sun. At that moment, Earth will be on one side of the Sun, and the comet will pass on the other side. The distance is not critically large. Could study this object in detail through telescopes, but the Sun will be directly in between us and the comet, making such observations from Earth extremely inconvenient, practically impossible. In fact, we noticed that several space observatories orbiting near Earth are specifically designed to study the Sun. These include the Solar Dynamics Observatory and the older SOHO Observatory. They are capable of observing the Sun while covering it with a special shutter, which allows them to study the near-solar regions of the sky. It is precisely these instruments that we will entrust with observing the comet as it passes behind the Sun. The next close encounter will take place on March 16th with Jupiter. This one will be very close, and given Jupiter's enormous mass, the comet will pass near enough for the planet to significantly alter its orbit. On the Extraterrestrial podcast, we discuss the latest news in the study of the universe. Recording and editing a video is not a quick process, but it gives us time to dive deeply into the topic. If you want to stay updated with space exploration and astronautics news as quickly as possible, subscribe to our Telegram channel, Extraterrestrial Telegram. Subscribe so you don't lose track. Link is in the description under the video. Pause. And here we move into romantic ideas. I would say, what is the romance of the 3 interstellar objects? Only one raises no questions: Borisov's comet. It is a comet in every respect. Nothing unusual in its motion, nothing special in the way gases evaporated from its surface. But the first one, ʻOumuamua, and the current 3I divided by Atlas raise questions in many directions. They don't quite match our expectations of natural icy bodies comets. Both ʻOumuamua and this one behave in very strange ways. In the motion of ʻOumuamua, astronomers noticed excess acceleration. That is, it was flying away from the Sun, influenced not only by gravity but also by some unknown forces. Let's leave that aside for now. The current comet entered the solar system in a very unusual manner. Its motion, its orbit, lies almost exactly in the plane of all the planetary orbits. It gives the impression that it had a mission to pass by most of the planets and approach them, and if that truly was a mission, it's a very precise one. If this is a spacecraft designed to study the planets of the solar system, then this is exactly how it should move. Whether this was the preliminary calculation of intelligent beings, or just a coincidence, we don't yet know, but the orbit does seem highly improbable. It's flying right in the plane of planetary motion, and passes more or less close to nearly all of them. Venus, and Jupiter, but it chose not to pass near Earth. It is behind the Sun at the moment of its closest approach to Earth, or rather, it will, since I am talking about October and November of this year. It creates the impression that some kind of preliminary calculation was involved to hide from observers, yet still explore the planetary system. Of course, all this could be coincidence or maybe not. These strange thoughts are encouraged by the well-known A.V. Loeb, American astrophysicist, who for many years has been watching interstellar objects with the thought that they could be alien space probes, and why not? After all, even if this isn't a probe, it is still a gift of nature to our astronomers, a sample of material born outside the solar system. 1. We were thrilled whenever meteorites fell to Earth, saying, "This is a gift from the sky." We don't need to travel to the planets to themselves throw pieces of their matter into the hands of scientists. That's right, meteorites are very valuable material. Now we say we don't need to fly anywhere besides. We don't yet know how to reach other stars. Samples themselves come to us. Material from other planetary systems. We have already witnessed this 3 times, and each time we have had no opportunity to study this material directly, to fly to it, collect samples, photograph it up close, obtain a detailed spectrum, and examine what these objects look like. Why not? Because they enter the solar system at enormous speed and quickly fly back out. Space exploration is a very slow endeavor. To prepare a spacecraft for a specific mission requires years and years. Meanwhile, yesterday the object arrived, and tomorrow it will already leave the solar system. This one entered with an incredible speed of more than 60 kilometers per second, and when it passes near the Sun, its velocity will reach around 78 kilometers per second. We have never seen objects moving this fast within the solar system, but it's understandable our solar system is moving. More precisely, this object is flying toward the direction of the solar system's motion. The result is extremely high relative speeds. Till we have telescopes, and we use them. So what have we learned about this object so far? It does resemble a comet. It evaporates as the Sun heats it, and here, again, we encounter surprises. Normally, comets begin to evaporate after crossing Jupiter's orbit, when they are already approaching the orbit of Mars. Because by then, the Sun's rays heat them strongly enough that the ice begins to sublimate. But this comet began evaporating much further out. It seemed as though the Sun was still too weak at that distance to heat it, yet it was already evaporating quite rapidly. By detecting hydroxyl molecules, astronomers calculated how much water the surface of this object is losing every second. Why hydroxyl? Because water molecules are fragile, and when they leave the comet's surface, ultraviolet rays from the Sun split them into hydrogen and hydroxyl, and by measuring the amount of hydroxyl, it is easy to determine how much water the comet is losing. The result, 40 kilograms every second. At first glance, that doesn't seem like much about 4 buckets of water per second, but it is a lot for such a cold region of the solar system where we are observing this process. But that's not the only peculiarity. The recently launched infrared space telescope noticed the evaporation of what we call dry ice frozen carbon dioxide. Generally, it sublimates more easily than water ice, but it is usually found in much smaller amounts in comets. Yet in this object, it turned out to be abundant, forming a dense temporary atmosphere around the nucleus. Astronomers call it a coma. From this comes the word comet, from the Greek word for hair, since comets were once drawn as a flowing mass of hair trailing behind a girl's head. That's how they were often imagined. This is the Extraterrestrial Podcast. Here every week you'll find new episodes with Orion Vega. Even aliens have already subscribed. What about you? And what else is unexpected? The unexpected thing is that astronautics might still play a role in studying this object. Although we cannot prepare a special probe in time, within 6 months, it will leave the central regions of the solar system, and we simply will not be able to catch up with this fast-flying traveler. But after all, we currently have several spacecraft operating in space, traveling toward planets and asteroids. Let's use them. It turned out that at least 2 such probes are ready to join the work. First, there is Psyche. Psyche is a spacecraft launched by American engineers at NASA, now heading toward the asteroid of the same name, Psyche. This is a large asteroid that most likely consists almost entirely of metals. It is extremely important to understand exactly what it is made of, what kinds of metals. That is why the Psyche mission is flying there. On board, it carries high-quality optical instruments, and it will pass not very far from 3i divided by Atlas. The second spacecraft was launched to study Jupiter's moon Europa. You remember, it is covered in ice, with a subsurface ocean of liquid water, and there could be life there. Two space probes are currently heading in that direction, one American and one European, and the European one, due to its trajectory, will pass fairly close to the trajectory of this mysterious comet, and with its instruments, it will also be able to study it better than we can from Earth. At least several space observatories, ones that monitor the sun, and those traveling now toward the asteroid and Jupiter's moon, will take part in investigating this comet. But is it really a comet? Let's return to the assumption that it might be an artificial object. After all, we've long been saying that civilizations across the galaxy should exchange information, should visit one another. Therefore, each time one possibility must be considered that visitors from another intelligent civilization are coming to us. And now, a paper has been published by young American astronomers who compiled, at the very least, the key points we need to consider in order to treat any visitor to our solar system as a potential artificial object. What important characteristics must it display for us to say, yes, this is not a natural body, yes, this is artificial? First, its shape, and here, ʻOumuamua is the example. You remember, it had a strange cigar-like, I would even say pencil-like. Its length was about 230 meters, and its width about 35, meaning its proportions were roughly 1:7. Among the millions of asteroids we have discovered in the solar system, not a single one has such a cigar-like, or let's say rocket-like form. Yet, ʻOumuamua, the very first to arrive from interstellar space, had precisely this form. Interesting. That should raise suspicions, and it did. Second, its motion. Again, let's return to ʻOumuamua. After passing close to the sun, it seemed as though it switched on rocket engines. Yes, perhaps not actual engines, but jets of gas evaporating from the surface of a comet-like body. This is something comets are well known for. As they approach the sun, one side heats up the side facing the sun, and from that side gas escapes into space. Such gas emission acts just like a rocket engine, and the comet slightly changes its trajectory. We are used to this, but in every such case, we always observe the escaping gas as the comet's tail. Yet ʻOumuamua showed us nothing of the kind. It behaved as though it had switched on an engine, but no gas emissions were detected. That too should raise suspicions. Third, its appearance, or as astronomers say, its spectral composition. In simpler terms, its color. The surface of any object reveals its nature. What looks different from ice? A spacecraft made of aluminum or stainless steel, like those of Elon Musk, will shine in a way completely unlike any natural body. The spectral composition of light reflected from the surface of an object can alert us and give a hint that it might be artificial. For example, why only reflected light? If it's a spacecraft, it has systems working inside. Any spacecraft is heated from within, and it also emits its own thermal, infrared radiation. And excessive infrared radiation is also evidence that points to the artificial nature of an object. And finally, narrowband emission. What does that mean? When we tune a radio receiver to a specific frequency, we have to enter a narrow band of frequencies or wavelengths. To the right and left, no signal, but on a specific frequency or wavelength there is a transmission. If we were to receive such a signal, or such narrowband radiation, from an object, whether in the radio range or in the optical, say with a laser, that would be a clue, or perhaps even solid evidence, that it is artificial. All these 5 signs I have mentioned should alert us and lead us to certain conclusions. And one last thing I want to say, from time to time, we make mistakes. More than once, astronomers have announced the discovery of a new asteroid, only to later realize it was an artificial object. But so far, it has always been man-made. More than once, we have spotted an unfamiliar object in the sky, never before seen in the solar system. We calculated its trajectory from its visible motion and were surprised. It seems it was launched from Earth several years ago, and each time, that turned out to be true. Recently, one of our first Soviet probes, sent to Venus but failing to reach it and instead ending up in orbit, was rediscovered after being forgotten. And not so long ago, the last stage of a Saturn rocket used in the Apollo program to send astronauts to the moon was also rediscovered. After sending them off, the stage itself flew past the moon and wandered into the solar system. It drifted, and eventually returned toward Earth, nearly striking our planet. It turned out to be our own creation. More than once, Artificial but human-made objects have been discovered. What we are waiting for, however, is the day when an artificial object will be discovered that was built by an extraterrestrial civilization. That would be truly fascinating. To avoid missing new stories about space from Orion Vega, subscribe to the Extraterrestrial Podcast and hit the notification bell. Let's find each other in the cosmic vacuum.